Let's try to divide two polynomials together. Notice 3x squared plus 9x minus 11 does not factor. This is actually prime. And for us to divide here, usually the first polynomial has degree higher than the second one. Before we start doing long division, let's recall a basic division problem. Let's try that. And we divide it by, let's say, 3. We ask ourselves, how many times, or about how many quantities, does 3 go into 9, right? That's really the key to a lot of these long division problems, is starting this off correctly. The answer here would actually be 3, right? And then what do you do with this 3? Then you go 3 times the red 3 will get you 9. And then where do you put this 9? We put this 9 right here. And the next step is subtract. So, first thing you do is ask the question. Then you multiply. Multiply. Let me spell multiply. Then you multiply. Then once you multiply, you subtract, right? You actually subtract. And when you put the subtraction bar here, all right, then when you subtract, you get 0. And then you ask yourselves, about how many times does 3 go into 0? And so we're back to question again. So 1, you question. 2, you multiply. 3, you subtract. Excuse me, I forgot the fourth step. The fourth step's really important. You need to bring down. So you got to bring down the 1 first. And when you bring down the 1, then you go back to the question, about how many times or how many quantities does 3 go into 1? And that would be 0 quantities. And then you start all over again. Okay, so 5, if you get to 5, you're doing a repeat of 1 through 4. And then you multiply, of course, and then you subtract. And then you get 1, and then you bring down. Now we have 10, and then we start to question again about how many quantities of 3 go into 10, and that would be 3 quantities. And then we have 9 because you multiplied, and then you subtract, right? And then now we have 1. Then we're at bring down again. And so there's a nice repetitive pattern here. Very, very nice repetitive pattern. 4. And then once again, you ask the question about how many quantities of 3 go into 14. We're going to say 4, and so on and so forth. So there is a nice repetition going on. Then you subtract. And then we have a remainder of 2. And notice, if you do this correctly, your place values tell you when to stop. So there's a nice finish line there, as long as you're being neat with all this. So we have a remainder of 2. This part here is what we call the quotient, which is the answer to a division problem. And then this over here is the remainder. We typically could add the remainder over the divisor. So we're going to go ahead and add the remainder of 2 and put it over its divisor. In this case, it's over 3. So we get 3,034 and 2/3. Mixed number, in other words. Let's do the same thing for polynomials. Notice you would, if the problem was 3,034 divided by 3, notice this is the setup, right? So if it's 3x squared plus 9x minus 11 divided by x plus 4, then the setup would be x plus 4 Well, how about I keep the same color scheme? How about I keep the x plus 4 here? And then we want to know about how many quantities of x plus 4 go into 3x squared. That's actually the first question. About how many quantities of x plus 4 go into 3x squared. And the answer to that is 3x. And where am I going to put the 3x? I put it over the x's. And then I'm going to draw a finish line right here. I should be ending at that finish line as long as you're neat with everything. Once you answer the question, now we multiply. When you multiply 3x times the quantity x plus 4, you get 3x squared plus 12x. And now we are at subtraction. But when you subtract, you have to use parentheses because our quantity is 3x squared plus 12x. Let's subtract. And we get a negative 3x. And then we ask the question again. About how many quantities does x plus 4 go into negative 3x? And the answer is negative 3. And now we're at multiply. Oh, I'm sorry. What did I forget to do after I subtract? According to our division algorithm, after subtraction is what? After subtraction is bring down. So don't forget to bring down. I got a little bit ahead of myself. I need to bring down the subtract 11. Now, ask the question about how many quantities does x plus 4 go into negative 3x? And the answer is subtract 3. So I didn't get that part wrong. I just forgot to bring down. Now, if you make a mistake, you correct it. So that way you don't make that mistake again. Or, you're trying to prevent that mistake from happening again. We are at multiply. So negative 3x and then subtract 12. Now when we subtract, you got to make sure you put parentheses. Put the parentheses there and take advantage of the distributive property, and we get a remainder of 1. So I'll write the 1 there. There's the remainder. That's often called the remainder. And remember your quotient. Your quotient is right here. And then the final answer is actually you take your quotient and then you add the remainder and put it over its divisor. And the divisor here is x plus 4. Okay. Now if you want to, I know you want to, go ahead and do the second example. Let's call this first example A. The second example is B. And you do the second example. Go ahead and pause the video. Do the second example. And if you need to check your answer, unpause the video to make sure you're writing down all the symbols in the right spot. Let's clear some space here. Remember to start off this long division problem, make sure you realize that 3x plus 5 is your divisor. And then we want to know about how many quantities of 3x plus 5 go into 12x squared plus 29x plus 15. And I'm going to start drawing the finish line here. Everything's going to be a nice straight column or columns. All right, let's ask the question. About how many quantities does 3x plus 5 go into 12x squared? And the answer is 4x. Now where do I put it? I'm going to put it right over to 29x. And now we're at multiply. If you multiply, we get 12x squared plus 20x. And now we're at the step called subtraction. When you subtract, make sure you put the quantities or the parentheses there. And then you subtract, and we get 9x. And now we are at the step called bring down. So bring down the plus 15. And now we ask a new question. About how many quantities does 3x plus 5 go into 9x? And the answer is plus 3. And now we're at multiply, and so we get 9x plus 15. Whoa! And now we subtract. And when you subtract, you put parentheses, and notice this time we have a remainder of 0. So if we have a remainder of 0, that means this divides evenly. And it turns out that 12x squared plus 29x plus 15 is factorable. So when it has a 0 remainder, we say it's actually factorable. Final answer is the quotient. The quotient is 4x plus 3. And since there is a 0 remainder, we are not going to write the rest of it. It would be silly. Here's a particular long division problem that requires a little bit more attention. Notice the first polynomial has degree 4, but it is not written in descending order. So when you write this division problem, make sure it's in descending order. The other thing you want to notice is that we're missing a place value, and the place value here is actually the x's. Notice there's a place value of x to the 4th, there's a place value of x to the 3rd, there's a place value of x squared, but there isn't a place value of x's. So let's write this first polynomial very, very carefully. Make sure it's in descending order. If you ever forget, which way to write the divisor, notice this translates to 4. How many quantities of 4 go into 8? So we typically write it like that. Let's write our divisor first. And then we draw our symbol. Negative 9x to the 4th minus 14x to the 3rd plus 4x squared plus 0 times x plus 15. And I'm going to draw that bar all the way to the 15. And I'm going to draw my finish line as well. Now we start off with a question about how many quantities of negative x squared minus x plus 2 go into negative 9x to the 4th. And the answer is 9x squared. And I'm going to put the 9x squared over the 4x squared. We are now at the step called multiply. So when you multiply here, make sure you remember you're using the distributive property. We go ahead and multiply, and we get negative 9x to the 4th minus 9x cubed plus 18x squared. And now we're at a step called subtraction. Now when you put subtraction here, you got to make sure you use parentheses. Use those parentheses very, very nicely and be very, very neat with everything. And we are going to subtract. Now we get negative 5x to the 3rd minus 14x squared, and we are now at the step called bring down. What are we going to bring down? We're going to bring down not necessarily the 0 times x, because that is a 0 quantity. Oh, I take that back. We are going to bring down the 0 times x. I'm working ahead a little bit, and the next step will actually indicate that. Plus 0 times x. You're going to see the importance of that 0 times x. We need that placeholder to exist. Now we're at the question again about how many quantities of negative x squared minus x plus 2 go into negative 5x cubed. And the answer is plus 5x. Now we're at multiply, and when you multiply, make sure you use the distributive property. And then we subtract. Draw the bar. When you're subtracting here, you notice you're very, very neat. We get negative 9x squared and we get subtract 10x. And now we're at the step of bringing down. What are we going to bring down? We're going to bring down a plus 15. We're at the question again about how many times does negative x squared minus x plus 2 go into negative 9x squared? And the answer is plus 9. Plus 9. And we're at multiply. We multiply. We get this, right? There we go. And now we're at subtraction. And notice we hit our finish line. Now we have a remainder of negative x minus 3. So remember, up on top, right here, is the quotient, and this is the remainder. How do we write our final answer? Well, we take the 9x squared plus 5x plus 9, take the quotient, and we're going to go ahead and add the remainder and put it over its divisor. And the divisor is negative x squared minus x plus 2. Let's circle that. Make sure you're showing your work very, very neatly. Notice all the columns are lined up. And what I mean by all the columns lined up, x to the fourth is below x to the fourth, x to the third is in a column, x squared are in a column, all the x's are in the column. And so these are place values. As you can see the place values. Look at all the constants. They're also all in a column. Use the factor theorem to determine whether the factor x minus 2 is indeed a factor of p of x is equal to 2x cubed minus 4x squared minus 3x plus 4. Why don't we do that? Let's first label our two examples. I'll call one to be example A and the other one to be example B. Now here's the factor theorem. If you haven't written it already, make sure you write it in your notes somewhere. Notice it is an if and only if statement. And how do we read these if and only if statements? You have to be very, very careful. We're going to read these as two separate sentences. And so let me break this apart. An if and only if statement is actually a two-way street. And the way that we're concerned about is actually this way. We're going to write this way as an if-then statement. So we're going to read this theorem from right to left, and I'm going to rewrite it in complete sentences, or in one complete sentence. So we say if P of C is equal to 0, then we could conclude that x minus c is a factor of the polynomial p of x. And so that's how we're going to interpret the factor theorem for these two examples. So for part A, c is equal to 2. All we gotta do is evaluate p of 2. If p of 2 gets you 0, then we could conclude that x minus 2 is a factor of the polynomial. Let's find p of 2. So p of 2 is an expression, and wherever you see an x, you just gotta put parentheses 2 and then close it with parentheses. Make sure you do the order of operations, do exponents first. And notice we get negative 2. But negative 2 is not equal to 0. And then therefore, we could conclude that x minus 2 is not a factor of the given polynomial. Let's go to example B, where the polynomial is different now. If you wanted to, if your notes look really difficult to read, you could call this P sub 1, and then you can call example B to be P sub 2. Use the factor theorem to determine whether the x plus 1 is a factor of the polynomial P sub 2 of x. In this case, c is equal to what? C is equal to negative 1. Now we're trying to evaluate P of P sub 2 of negative 1. P sub 2 of negative 1. We get parentheses, negative 1 raised to the 4th, plus negative 1 raised to the 3rd, minus 6 times negative 1 squared, plus 6. What is this? This is actually 1 minus 1. Subtract 6, add 6. We do get 0. What's our conclusion? Therefore, the factor x plus 1, well, I should say, the quantity x plus 1 is a factor of P sub 2 of x. Let's circle our final answers. More importantly, you should be able to state the factor theorem by memory and show your work. Your work is just as important. You're really demonstrating procedures here and not just answers. For the next two examples, examples A and example B, we're going to perform a procedure called synthetic division. It's really a shortcut for long division for monic polynomials. What are monic polynomials? Well, monic polynomials are polynomials where the highest degree has a coefficient of 1. So in this case, the monic, it's really a monic binomial. So if this is a shortcut for a monic binomial, we got to make sure the coefficient in front of the x is 1. Over here, this is also a monic binomial. The coefficient must be 1 in order to do this procedure called synthetic division. Without this coefficient of 1, the patterns don't follow. So this is really important. We're going to take x plus 5 to be the divisor. So what would the long division look like? Let me remind you that before you did this with x plus 5 and you asked yourselves how many quantities of x plus 5 go into what? X cubed plus 0x squared minus 21x plus 20. Well, for synthetic division, we're going to do things a little bit differently. Instead, we're going to visualize that the factor would be x minus c. So remember, from the factor theorem, you would go x minus c. So in our case, c is equal to negative 5. We put this negative 5 up here in a little box. So we're going to begin the procedure of synthetic division. Now we're going to take all the coefficients of the polynomial, which is 1, 0x squared, negative 21x, and then 20. So these coefficients acts like placeholders. These coefficients actually act like placeholders. The first thing we're going to do is I'm going to draw a line here. We're going to bring down the 1. We'll bring down the 1. And we're going to take this 1 and multiply it to negative 5. We get negative 5. Take that negative 5 and place it in the next column. And then we add. If you add that vertically, we get negative 5. And then we multiply again. We take this particular negative 5 and multiply it to this negative 5. We get 25. And where do I put that 25? I put that 25 in the next column. And then we add again. We repeat this procedure until you get to the very last column. So what's 4 times negative 5? We get 20. I'm sorry, we get negative 20. And then we add. And if your remainder is 0, that's actually your remainder now. If your remainder is 0, then we could actually read the quotient. The quotient is actually 1 degree less than the original polynomial. So this is actually saying x squared minus 5x plus 4. So there's your quotient. Let's summarize what just took place. X cubed minus 21x plus 20 divided by the factor, or divided by the divisor of x plus 5 gets you this, x squared minus 5x plus 4. You get a quotient with 0 remainder. Go ahead and try to do example B on your own. You could pause the video, and when you're ready to check your answer, go ahead and unpause the video and reveal the solution. So if we look at this as x minus c, we're going to see that c is equal to negative 3. We take this negative 3 and put it up in the upper left-hand corner, and now we're going to read the coefficients of the original polynomial. We get 1, we get 0x cubed, we get negative 12, we get negative 7, and then we get a 3. Remember, the first step is to draw a bar and then bring down the 1. And now you just simply multiply and add. Notice we get 2 times negative 3 here, which is negative 6. So when you add this, you get a remainder of negative 3. So how do we write our final division problem? Well, let's write our quotient first. Our quotient is 1 degree less than the original polynomial. There it is. And let's add the remainder over the divisor. The divisor was x plus 3. You could write it like that as an acceptable answer, or you could write it like this. Either one of these are acceptable. I'm going to circle our final answers. Make sure you show your work as well. I'm going to go ahead and circle the work. The work is very important. You are demonstrating procedures in mathematics. Use the remainder theorem to find P of 3 for this particular P of x. Notice P of x is a degree 4 polynomial in descending order. In order to use the remainder theorem, we're going to assume that we're going to divide P of x by x minus 3. So what we're going to do is, in order to find a remainder, there's got to be a division problem. So it's really this. But the remainder theorem says we can take a shortcut. And that shortcut is simply identifying your C value. Your C value here is 3. And then let's evaluate P of 3. So whenever you see an x, you're just going to put parentheses and then a 3 in there. Pretty straightforward. make sure you use parentheses, make sure you use order of operations to exponents first. So this is the opposite of 81, and then this is plus 81, and then I subtract 6 and a plus 8. Notice we get a positive 2. So the remainder here is 2. Therefore, the remainder is 2. Let's use synthetic division to check. You know, our C is actually 3, so we could put this in the upper left-hand corner. We take the coefficients of your polynomial, and remember, you bring down the -1, and then you simply multiply and add. Notice you get 3 times -2, or -2 times 3, which is -6. And when you add that, we get the remainder of 2. And notice it does check. I'm going to circle this as my final answer. I'm going to circle the work as well. The work shows the procedure on how to get your answer.